This spectacular feather-shaped iridescent cloud was imaged by Curiosity rover just after sunset on Mars. Studying the colors in iridescent clouds tells scientists a lot about particle size within the clouds and how they grow over time. While most Martian clouds hover no more than 37 miles above the ground and are composed of water ice, these clouds appear to be higher in elevation where it's very cold. That suggests these clouds are made of carbon dioxide or dry ice. These rounded boulders are located in an area called Castle Henley's in Jezero crater on Mars. They are believed to have been washed into the crater by strong flood waters billions of years ago. Scientists have identified that this occurred during one of the three major periods in the development of the lake and river system that occupied Jezero in the ancient past. Here is another view of Castle Henley's from above. This image was taken by NASA's Ingenuity helicopter. At the time this image was taken, the helicopter was at an altitude of about 40 feet in the air. This amazing video shows Perseverance rover using its auto navigation or AutoNav technology to drive on Mars. AutoNav allows the rover to autonomously replan its route around rocks or other obstacles on its way to a pre-established destination. In total, the rover drove about 574 feet during this mission. The first 26 feet were based on commands sent up earlier by rover drivers, allowing Perseverance to build a 3D map of the terrain under and around it. This map allows the AutoNav function to assess the safety of available paths at the rover's location. Once AutoNav takes over, the rover autonomously chooses a path to reach the intended destination, continually imaging around itself to maintain a 98-foot by 98-foot map centered on the rover. This is Lunokhod 2 crater, which is approximately 20 feet in diameter. This panorama shows a river environment in Jezero crater that's billions of years old. An ancient lake and river system once existed in Jezero, and if microbes ever lived here, then signs of them could be preserved in these rocks. Different rock layers here also record different parts of the Jezero crater's history. The flat, light-colored rocks in the area were deposited on the banks of a river flowing slowly across the landscape. The boulders seen in the distance were deposited later, likely by fast-flowing water. This peculiar outcrop here is likely a remnant of a lava flow which has now mostly eroded away. Lab equipment on Earth can accurately measure when a volcanic rock was formed, so if a sample of such lava could be returned to Earth in the future, then we may know when and for how long water flowed into Zero. This mound of rocks on Mount Sharp has a number of naturally occurring open fractures, including one that's roughly 12 inches tall and 16 inches wide. These kinds of open fractures are common in bedrock both on Earth and on Mars. This sombrero-shaped rock was likely formed due to a process known as case hardening. This is where the outer shell of an exposed rock surface hardens either due to chemical weathering and a relative softening of the interior or hardening of the exterior due to the development of a rind. This can cause the interior of the rock to be preferentially eroded away, leaving behind interesting hollowed-out looking shapes. Both versions of this case hardening process are often closely associated with near-surface water-rock interactions, and so this could have interesting implications for past climate and surface water on Mars. Interesting Martian rocks surround Perseverance rover in this panorama showing an ancient river delta. The delta sits in the Zero crater, an area where scientists surmise that billions of years ago a river once flowed into a lake and deposited rocks and sediments in a fan shape. Deltas are believed to be the best places on Mars to search for potential signs of ancient microbial life. Therefore, arrival at the Zero Delta had been a primary goal of the Perseverance mission since the rover landed on Mars. The panorama here shows sedimentary rocks of great interest to scientists. The Perseverance rover has abraded the surface of several rocks in this area and acquired compositional information. It has also collected rock samples that the Mars Sample Return Campaign could bring back to Earth in the future, enabling detailed studies as part of a search for signs of ancient life. This lower portion of a Martian dust devil was captured by one of the nav cams on Perseverance rover. Using data from the imagery, NASA scientists determined that the dust devil was about 2.5 miles away and moving east to west at about 12 miles per hour. They also calculated its width to be about 200 feet. While only the bottom 387 feet of the swirling vortex are visible in the camera frame, scientists used the dust devil's shadow to estimate its full height at about 1.2 miles. These rhythmic rock layers have a repetitive pattern in their spacing and thickness. The patterns might have been caused by weather or climate cycles occurring while the sediment layers were being deposited, such as dust storms happening at regular intervals in the ancient past on Mars. Perseverance rover captured this view of the location where it was parked for several weeks during Mars solar conjunction, a period when engineers stopped sending commands to spacecraft on the red planet. During this time, Mars and Earth are on opposite sides of the Sun, which expels hot ionized gas that can interfere with radio signals sent between the planets. This image shows the details of the downwind face of Namib Dune. The site is part of the Bagnold Dunes field along the northwestern flank of Mount Sharp. Images taken from orbit have shown that dunes in the Bagnold field move as much as about 3 feet per Earth year. Sand on this face of Namib Dune here has cascaded down a slope of about 26 to 28 degrees, and the top of the face is about 13 to 17 feet above the rocky ground at its base. As on Earth, the downwind side of these Martian dunes have a steep slope called a slip face, where accumulating sand flows in mini avalanches down the face. Curiosity rover used its mast camera to capture the geologic details within this sandy, hill-lined area while the rover was traveling to reach another site. In this scene is a hill nicknamed Orinoco within a sulfate region and Upper Mount Sharp in the distance. NASA's Perseverance rover took some rock samples after drilling holes into the rock seen here, which is located at Jezero crater. When Perseverance ground away the surface of the rock, scientists could tell that it had been oxidized, judging by the difference in color between the outer surface and the freshly exposed patch. Here is the same rock after the drill and shows two holes where the rover's drill obtained chalk-sized samples from the rock. The results from these samplings support what NASA had already hoped and suspected, but needed more hard evidence to prove the idea that Jezero crater rocks had been exposed to water for a long time. The samples collected were of crystalline igneous rock, meaning rock that solidified into crystals from hot lava or magma. The rocks also show signs that they were chemically changed, weathered and laced with added salt minerals likely left when nearby water evaporated. Scientists think that the bands of rock seen in this image may have been formed by a very fast, deep river in the past. The curved rock layers are called the curvilinear unit, and they had previously only been seen from space. Scientists are also debating what kind of powerfully flowing water formed these curves. A river like the Mississippi, which winds snake-like across the landscape, or a braided river like Nebraska's Platte, which forms small islands or sediment called sandbars. When viewed from the ground, the curved layers are arranged in rows and appear to ripple out across the landscape. They could be the remnants of a river's bank that shifted over time, or the remnants of sandbars that formed in the river. The layers were likely much taller in the past though, as scientists suspect that after these piles of sediment turned to rock, they were sandblasted by wind over the course of eons and carved down to their present size. Curiosity rover snapped this picture of a rock with a series of long, slender spikes sticking out of its side in Gale crater. While it may look strange, it is likely the result of many ripples in the rock and a lot of erosion. This dark gray rock appears to be so fine-grained that the Mali instrument of Curiosity rover cannot resolve grains or crystals in it. This means that the grains or crystals, if there are any at all, are smaller than about 80 microns in size. Some wind-blown sand-sized grains or dust aggregates have accumulated on the surface of the rock, but this surface is clean compared to, for example, the pebbly substrate below the rock in the upper and lower right in this image. Curiosity rover found preserved ancient mud cracks that scientists believe were formed after long cycles of wet and dry conditions over many years on Mars. The discovery marks the first evidence of these wet-dry cycles on Mars. The cracks were found while the rover explored a transitional region between an area enriched with clay minerals and one enriched with sulfate minerals. The hexagonal shapes in the mud cracks are similar to those found at locations on Earth such as Death Valley National Park's racetrack playa. They form only after many years of alternating wet and dry conditions. When the mud cracks initially form, they have sharp T-shaped angles within their pits. After being gently rehydrated many times, those sharp angles soften into Y shapes that become ridges as the rock is eroded. Evidence pointing to wet-dry cycles is exciting to curiosity scientists because while no one is exactly sure how life first forms, one prevailing theory suggests that these wet-dry cycles are supportive, perhaps even required. The conditions that sustain microbial life, a long-lasting lake for example, differ from those that scientists think kickstart the chemical reactions that might lead to life. Driving those chemical reactions are long chains of carbon-based molecules called polymers, which require just the right conditions. Water is needed to mix chemicals into a soup where they can react with one another. Too much water will dilute the soup, making it difficult for polymer-forming chemical reactions to occur. Too little water and the chemicals can't adequately mix and react. Wet-dry cycling can strike a balance between the two. Curiosity rover captured this incredible panorama while driving toward the center of this scene, an area that forms a narrow pass. The hill on the right is Bolivar, and on the left is Deep Dale. The floor of the vast Gale crater is visible in the background in the upper right.